Well, you may have heard vectors defined as quantities that have magnitude and direction. But what does that mean? Well, this vector 3, 1 is in fact 3 along in the positive x direction and 1 up. So it looks like this. So from tail to head, you're going 3 along and 1 up. That's why the arrow is in that direction. But this vector can be placed anywhere in the plane. So it can move around as long as from tail to head, it's always 3 along and 1 up. Now we can express that in terms of the basic vectors I and j. Remember, I was the vector which goes 1 along and 0 up. And you'll notice, I'll just point this out again, that I is here in heavy print. Of course, if you were writing it down, as Francesca was describing, we'd underline it. OK, what about the j? Well, j was the vector which went 0 along and 1 up, parallel to the y-axis. And we can now write 3, 1 in terms of I and j as 3 times I, 3 in this direction, plus 1 times j, 1 in the vertical direction. But there's another way of describing a vector that's not in terms of its components. You can describe a vector in terms of its magnitude, that is its length, and its direction. Now, as far as the magnitude is concerned, we can use Pythagoras' theorem, because the magnitude or length of this vector is the square root of 3 squared plus 1 squared, the square root of 10, and the square root of 10 is equal to 3.16 to 2 decimal places. What about the direction? Well, the direction is described as the angle the vector makes with the positive direction of the x-axis. We've marked it theta here. And as you can see, tan theta is 1 over 3. So the direction here, theta, is the arctan of 1 over 3, which is 18.43 degrees to 2 decimal places. So that means direction 18.43 degrees, magnitude 3.16.
Well, I've got a problem here, which involves adding